In this video, we will be looking at rational inequalities. One thing we're going to have to remember is that when we're dealing with rational expressions, we're dealing with a fraction. First, we're going to talk about the case where a fraction is positive. A fraction is positive if the numerator and denominator have the same sign. They can either both be positive or both be negative. What that's saying is if you have a positive divided by a positive, you get a positive, and if you have a negative divided by a negative, you also get a positive. If we have a fraction that's negative, the ways we can get that is if the numerator and denominator have different signs. So one is positive and the other is negative. It doesn't matter whether your positive is in the numerator or the denominator. If there is one positive and one negative, then the overall fraction is negative. We're going to start by looking at rational inequalities where one side is 0. The first thing we're going to do, step 1, is set the numerator equal to 0 and solve for the zeros of the function. So what we're doing in that case is we are finding the values that make the overall fraction equal to 0. In step 2, we're going to be setting the denominator equal to 0 and solving for the excluded values. Those are the values that are not allowed for the variable, so they can't be in our final solution either. We are going to mark both the zeros and the excluded values on a number line. Then, just like we did with quadratic inequalities, we're going to use test values in each interval to check to see if the interval is positive or negative. And then finally, we're going to pick out the intervals that we want for our final solution. So we're going to start with 3x minus 10 over x plus 4 is less than 0. For step 1, we set the numerator equal to 0. So that's 3x minus 10 is equal to 0. If I add the 10 over, I get 3x equals 10. And if I divide both sides by 3, I get x is equal to 10/3. That is the value of x that will make the entire fraction equal to 0. For step 2, we set the denominator equal to 0. So x plus 4 equals 0. I can move the 4 over, and we get x equals a negative 4. That is the excluded value. That is the only value of x that is not allowed. So now we are going to place these on a number line. Again, my number line doesn't need to be to scale, but it does need to be in order. So negative 4 is less than 10/3, so my negative 4 will go over here. My 10/3 will go over here. And now I need my test values. And like I said, this is very similar to when we did it with quadratic inequalities. So something less than negative 4 could be, say, negative 5. Something between negative 4 and a positive 10/3 could be 0. And something bigger than 10/3, maybe 10. Your test values don't have to be the same as mine. As long as they're in the interval, it's good to go. What's going to be a little bit different is how we plug them in. You are more than welcome to plug in your test values into this expression as a whole, but I think making a sign chart for the numerator and denominator makes it a little bit easier on me. So for my rows of my little sign chart that I'm going to make, I'm going to have my numerator, the 3x minus 10, my denominator, the x plus 4, and then the whole fraction, 3x minus 10 over x plus 4. In my columns, I'm going to put my test values, negative 5, 0, and positive 10. What I'm going to do is I'm going to plug in my test values into my numerator and denominator separately. So negative 5, plugging it into 3x minus 10, that's a negative 15 minus 10, that's negative. Plugging in 0, that's negative. Plugging in 10, 30 minus 10, that's a positive 20. I'm not going to do the same for my denominator. Negative 5 plus 4, that's negative. 0 plus 4 is positive. 10 plus 4 is positive. And now we're going to use that idea that if they're the same sign, then the entire fraction is positive. If they're opposite signs, then the entire fraction is negative. So the entire fraction will be positive because we have a negative over a negative, then negative because they're different, and then positive because they're both positive. So that means my number line will go positive, negative, positive. So now I just need to figure out what parts of my interval I want. Remember back when we solved for the numerator equal to 0? I'm going to decide whether this gets an open circle or a closed circle based on my inequality sign. There is no equal to, so on 10/3, I'm going to have an open circle. If it had an equal to as an option, then it would be a closed circle. But since it doesn't, it will be an open circle. What I do in step 2, this value is not allowed, ever. When you set the denominator equal to 0, that value will not be included. So what you get in step 2 will always be an open circle. So I have an open circle on -4 and an open circle on 10/3. And I want the section of number line that is less than 0. So I want the negative part. The negative part is the stuff in the middle. So my solution will be -4 to a positive 10/3. And since they're both open circles, I'll have parentheses on either side. So as long as I plug in a number between -4 and a positive 10/3, this inequality should be true. We're going to try another one. We have x squared minus 11x plus 28 over x squared plus 6x plus 9 is less than or equal to 0. So for step 1, we set the numerator equal to 0. So that's x squared minus 11x plus 28 is equal to 0. That's going to factor into x minus 7, x minus 4. So that gives me x is equal to 7 and x is equal to 4. For my denominator, that's step 2. We take the denominator and set it equal to 0. That's x squared plus 6x plus 9. That's going to factor into x plus 3 times x plus 3. And either way, I get x is equal to a -3. So on my number line, I need a -3, a +4, and a +7. And then I need to pick some test values. Something less than -3 could be -5. Something between -3 and +4 could be 0. Something between 4 and 7 could be 5. And something bigger than 7 could be 10. So those are going to be my test values. I'm now going to set up my fraction into my sign chart so I can start figuring out where this is positive and where this is negative. So my numerator, I'm going to write it in factored form, was x minus 7 times x minus 4. My denominator was x plus 3 times x plus 3. And then I have the whole fraction x minus 7, x minus 4 over x plus 3, x plus 3. So that makes the rows of my chart. For my columns, I use my test values. So -5, whoops. Yep. -5, 0, +5, and +10. Well, that's what I did. I put a line where there shouldn't have been one. That one's a fraction. There we go. So starting with my numerator, if I plug in -5, I get a negative times a negative, that's a positive. Plugging in 0, I get a negative times a negative, which is a positive. Plugging in 5, I get a negative times a positive, which is negative. Plugging in 10, a positive times a positive is positive. Now into my denominator, -5 plus 3, that's -2. Negative times a negative is a positive. 0 would give me positive times positive. Again, positive times positive. Again, positive times positive. And now I just need the value of the overall fraction. So positive over positive, that's the same. Positives, the same, then different, and then positive. So the overall fraction goes positive, positive, negative, positive. So we have positive, positive, negative, positive. So the inequality symbol tells me whether these are going to be open circles or closed circles. Since equal to is an option, 7 and 4 are going to have closed circles on them. What I get in step 2 for the denominator is always an open circle. I want the sections of number line that are less than or equal to 0, so I want the negative section, which is right here. So I only want 4 to 7. And since they are closed circles this time, they are going to get square brackets. Next up, we're going to start looking at rational inequalities that have two terms. So if there's more than one term, what we're going to do is put them together so that there is only one term. So we're going to combine our fractions, and then we're just going to solve like we have been. As a note, as you can see at the bottom, it says you cannot multiply both sides by the common denominator. The reason for that is we lose a solution, and it's possible that you're multiplying both sides by 0, and that's not allowed. So we are just going to work on putting all of our terms on one side and combining them into one overall term, and then solving like we have been. So next up, we're going to look at 8 over x plus 6 minus 7 over x minus 5 is greater than 0. So what we're going to do on that left-hand side is we are going to subtract them so that we can combine them into one term. So right now we are looking at 8 over x plus 6 minus 7 over x minus 5. But we need a common denominator so we can combine them. Right now my first fraction already has the x plus 6. My second fraction doesn't, so it needs an x plus 6 in the numerator and denominator. My first fraction doesn't have the x minus 5, so it needs an x minus 5 in the numerator and denominator. All right, so now they have the same denominator, x plus 6 times x minus 5. Our numerator is 8 times x minus 5 minus 7 times x plus 6. I'm going to distribute through, and then I'll combine my like terms. So we have 8x minus 40 minus 7x minus 42 all over x plus 6, x minus 5. And that's going to simplify. 8x minus 7x is just 1x. And negative 40 minus 42 is a negative 82 all over our x plus 6 times x minus 5. So now, instead of thinking of this problem this way, I can rewrite it as x minus 82 over x plus 6 times x minus 5 is greater than 0. So just replacing it with the one term equivalent expression. Now we can do our step 1, step 2, and so on. For step 1, we set the numerator equal to 0. So x minus 82 equals 0, x equals 82. For step 2, we set the denominator equal to 0, x plus 6 times x minus 5. And that'll give us x equals a negative 6 and x equals a positive 5. So on my number line, I'll have a negative 6, a positive 5, and a positive 82. I need to pick out some test values. I'll use a negative 10, 0, positive 10, and a positive 100. So setting up my sign chart, my numerator is x minus 82. My denominator is x plus 6 times x minus 5. And then I have the whole fraction. For my columns, I'll have my test values of -10, 0, +10, and +100. Plugging in a -10 into my numerator, I get negative. Plugging in 0 is negative, 10 is negative, 100, that one's finally going to be positive. Looking at my denominator, plugging in -10, I get a negative times a negative, that's positive. Plugging in 0, a positive times a negative is negative. Plugging in +10, that gives me a positive. And plugging in 100 gives me positive. So they're different, so it's negative. They're the same, so it's positive. They're different, so it's negative. They're the same, so it's positive. So my number line goes negative, positive, negative, positive. Finally, we need to know what our endpoints look like and pick out the parts of the interval that we want. My numerator, we look at the inequality symbol. Since equal to is not, we'll have an open circle. My denominator always gives me open circles. So all three of these are going to be open circles. And I want the sections of number line that are positive. So that would be this section here and this section to the right forever. So the way I'm going to write that in interval notation will be -6 to +5 in parentheses, union 82 to infinity, also in parentheses. So all the steps are the same. It's just a matter of putting it all together into one and then following through. It's also possible that we will come across a rational inequality where neither side is equal to 0. We're going to follow this kind of like you might expect. The first thing we want to do is move everything to one side of the inequality, so we do have 0 on the other side. Then we're going to put our terms together so that we only have one fraction, and then we'll follow the same steps. So let's give it a try. We have 3x minus 10 over x plus 4 is less than 2. First things first, we want to move everything to one side. So I'm going to subtract 2 from both sides. That will turn this inequality into 3x minus 10 over x plus 4 minus 2 is less than 0. I want these to have the same denominator, and right now the first fraction has a denominator of x plus 4. My second fraction has a denominator of 1. So what I can do is I can multiply the second fraction, if you will, thinking of my 2 as 2 over 1, by x plus 4 over x plus 4. That way, it will have a denominator of x plus 4, and I can put them together. So I'm just going to look at that left-hand side for a second. We have x plus 4 as our denominator. Our numerators are 3x minus 10 minus 2 times x plus 4. So that's going to be 3x minus 10 minus 2x minus 8 all over x plus 4, and that's going to simplify into x minus 18 over x plus 4. So all I've done is I subtracted the 2 to the left-hand side. I turned it into a fraction with the same denominator as the fraction I already had, combined my like terms to make it into one whole fraction. So I've rewritten my original inequality. So now I'm looking at x minus 18 over x plus 4, and we had this left-hand side as less than 0. So then we just do our steps. Step 1, set the numerator equal to 0. If x minus 18 equals 0, then x is equal to 18. For step 2, we set our denominator equal to 0. If x plus 4 is equal to 0, then x equals a negative 4. We set up our number line. I need a negative 4 and a positive 18. Need to pick some test values. I'll use a negative 10, 0, and 20. We'll try that. First row is my numerator, x minus 18. Second row is my denominator, x plus 4. Final row is the entire fraction. And then my columns are my test values, -10, 0, and +20. Plugging in -10, -10 minus 18, that's very negative. 0 minus 18, that's negative. 20 minus 18, that's positive. -10 plus 4 is negative. 0 plus 4 is positive. 20 plus 4 is positive. Same sign negative, different sign, oops, sorry, same sign positive, different sign negative, same sign positive. So my number line goes positive, negative, positive. The inequality symbol does not have equal to as an option. So my numerator value that I got is going to be an open circle, and my denominator value is always going to have open circle. So I have open circles on both of these. And I want the sections that are less than 0. So I want the negative, and it looks like to be this middle section. So I want -4 to +18 with parentheses on both sides. So when it comes to rational inequalities, the same idea that we had in quadratic inequalities follows. We still want to get 0 on one side. We want to find the values that make it 0, but we're also going to find the values that we can't include. We put them on a number line. We figure out where our number line is positive and negative, and we take the sections we want.